Our goal is to find the limit of 1 plus 2 divided by x raised to power x as x goes to infinity. What are we going to do? We're going to write this as y equals to 1 plus 2 over x to power x, then take the ln of both sides. Okay. Take ln of both sides. Ln of y is equal to the ln of quantity on the right-hand side. 1 plus 2 over x to power x. Remember that from algebra, if you have ln of a quantity raised to power n, you can write n in front of the ln. Okay, so this is your n, which needs to be written in front of ln. So you get ln of y equals to x times ln of 1 plus 2 divided by x. Very good. So now if you take the limit of ln on the right and limit of ln on the left, what do we see? So take a look. The limit of ln of y as x goes to infinity is equal to the limit of x times ln of 1 plus 2 over x as x goes to infinity. We don't have any issue with the limit on the left-hand side because it only has a y in it. But what about the limit on the right-hand side? This guy is equal to infinity times ln of 1 plus 2 over infinity, which is 0. You end up with infinity times ln of 1, or you end up with infinity times 0, which is indeterminate form. So what are you going to do? You're going to go back to this quantity and rewrite it. We must rewrite this quantity so we get 0 over 0 or infinity over infinity, so we can apply L'Hopital rule. This is our goal. Perfect. So what do we have here? I'm going to copy down the whole thing. The limit of ln of y as x goes to infinity can be written as the limit of, I'm going to play around with my x a little bit. I'm going to keep my ln 1 plus 2 over x. Now I'm going to divide this by 1 over x, then take the limit as x goes to infinity. When I write it this way, this becomes ln of 1 divided by 1 over infinity, or I end up with 0 over 0. Now I can apply L'Hopital's rule. Very good. Everything seems working perfectly. Remember L'Hopital's rule. In applying L'Hopital's rule, if the limit of f of x divided by g of x, x goes to a is 0 over 0 or infinity over infinity, then the limit of f of x over g of x as x goes to a is the same as the limit of f prime of x divided by g prime of x as x goes to a. This is your L'Hopital's rule. So now that we rewrote everything, we can apply L'Hopital rule for the right-hand side. So limit on the left, limit of ln of y. Pay attention, everyone. I'm not applying L'Hopital's rule on the left-hand side. My left-hand side stays the same. Limit of ln of y stays the same, is equal to. Now on the right-hand side, I'm applying L'Hopital's rule. I'm going to take the derivative of ln of 1 plus 2 over x and divide it by the derivative of 1 over x as x goes to infinity. Let me use the same color. So we only apply L'Hopital's rule on the right-hand side. We don't have any issue with the left-hand side. You cannot change left-hand side. Unchanged. But for this part, we're applying L'Hopital's rule. Very good. So continue the process. The limit of ln of y as x goes to infinity is equal to the limit of, now let us take the derivative of ln. Remember that if you have ln of u and you're taking the derivative, it is u prime divided by u. Okay, so on my numerator, I have to apply 1 plus 2 over x derivative divided by, write this guy down here. I need this a little bit space. Oops. Okay, this is better now. Divided by 1 plus 2 over x divided by the derivative of 1 over x is negative 1 over x squared, and x goes to infinity. So the limit on the left stays the same. We are not changing anything. Limit of ln of y as x goes to infinity is equal to the limit. Well, here I have a long division, and the derivative of 1 plus 2 over x is negative 2 divided by x squared over 1 plus 2 over x divided by negative 1 over x squared. Okay, hope you can read this easily. Very good. So basically, we can simplify this further. You can cancel out x squared, you can cancel out x squared, you can cancel out these negative signs, and x goes to infinity. So this guy can be written as the limit of, simplify this guy further. The whole denominator disappears, so you get 2 divided by 1 plus 2 over x as x goes to infinity. This guy becomes 0. So what do we see here? This is equal to 2. Hey, I have limit on the left, which is 2. But what's the meaning of that for my y? ln of y is equal to 2. So y is e to power 2, everybody. This is the part that the students usually miss. Y is equal to e to power 2. But what was y? Let's go back up here. My y is 1 plus 2 over x to power x. This is the limit that I wanted to find. So your conclusion is, so the limit of 1 plus 2 over x to power x as x goes to infinity is e squared. So this is what we are looking for. This is the value for the limit. The limit exists, and if you want to get some numbers out of it, you need to use a calculator to approximate. have a 2. Y is e to the second power. It means that the limit is e to the second. So a short summary for you. We wanted to find the limit of 1 plus 2 over x to power x. We wrote y equals to 1 plus 2 over x to power x. We took the ln of both sides. Ln of y is equal to ln of 1 plus 2 over x to power x. We used algebra to write the exponent in front of ln, and then we took this x and wrote it on the denominator as 1 over x. Then, if you take the limit, you end up with 0 divided by 0, so you can apply L'Hopital's rule. So, take the derivative of the numerator, take the derivative of the denominator, your left-hand side stay unchanged because there is no 0 over 0 or infinity over infinity to apply. So, after taking the derivative and simplifying it, you see that the limit of ln of y is 2. So, ln of y is equal to 2. It means that y is e to power 2. So, the limit of y is e to power 2. But what was y? Y was 1 plus 2 over x to power x. So, this limit is e squared. You can use a calculator to approximate this number as well.